So what you might have seen that we went a little bit too deep into subjects like electromagnetics as well as electromagnetic signal processing systems, mm, s- and little bit of mathematics also. Okay, so first I would like to say that don't worry about it. It actually to be means frank about it, astronomy is a very vast subject where you can have, you can do multiple things, means like you can have many domains integrated into one. You have electronics person working in it, mechanical person working in it as well as physics is there already. Okay, so to give a glimpse of everything, so we went a little bit too deep, but those who are from the other streams might like that. Uh, for that purpose we went a bit deep, not only be not only being a stickler to the physics and the workings of astronomy. Okay, so that also will come in the later part, later half of the course. Okay, so uh, so again, very good evening to all. Well, I am Harshav Nastanti, and I am currently a research scholar and pursuing my PhD under the supervision of Professor Abhirup Datta, and who is also the course instructor. You all uh, seen him in videos. Okay, so let's start first discussing about some questions in the discussion forum, which I might have answered or might have skipped. Okay, so let's start the discussion with the first question. And so here, means one of you asked why, means according to conversation. So asked about why the intensity is independent of the distance, because we see that it is the kind of uh, means area over r square, right? Area of the source over the r square. This was the question. So actually this has to do with the to clarify again, this has to do with the construction of the means angle system. Okay, how an angle is defined. First of all, say angles was initially defined in terms of radians. And that radian means that the arc length, whatever the arc length you means traveled in the circle, for example, and the distance, means distance from the center. If you take a ratio of that, that will define the angle, how much angle you travel. Okay, regardless of r, however long r be. Okay, the arc length will vary accordingly. So that's why it was termed as an angle. Okay, so they are proportional to each other. Okay, and also if you go to trigonometry, how a sine of theta is defined, means like p by h, those are ratios, right? Those remains constant. If you normalize any value of perpendicular by hypotenuse, you will always, means like calculate a ratio, you will always get sine of theta. Means theta is a factor which is always a kind of constant, regardless of being whatever the length of hypotenuse or the perpendicular be. Okay, similarly, say for example, this is all about 2D. Okay, if we extend this concept to 3 dimension, so if we extend this concept to 3 dimension, then there will be like a 3 dimensional angle should be defined, right? It say for example, you have a cone structure. Those are kind of typically a 3 dimensional angle you can imagine as. Okay, so from that perspective it all went, means like so this theory came up from there only. For example, say if you have a 2D angle, you can say along this line this is this much theta, along this line this much theta, but what about the diagonal and this, how those are defined? So to do that, uh, they found that okay, whatever the area subtended by the angle is, okay, by the distance square, is kind of a representation of your 3D, means kind of 3D equivalent angle. So and that ratio remains proportional throughout. Means if you go very, means far away also, the steradian value will be constant for that amount of area, means the whatever the larger area it covers. Okay, so in that way the specific intensity and all is independent of distance. Okay, uh, Any questions regarding this? Means like anything, any doubts about such this explanation or something? Hello, I'm audible, right?
Yeah, you are audible.
Yeah. So the uh, so actually one of your students was pointed out there was a mistake in the calculations here. So I appreciate, means actually we are thankful to you, so you pointed out the mistake here. So we will change it into the lecture slides, and we will put that on note, and when we circulate the slides, that those things will be corrected. Okay. So now moving on to the next thing. Now one one of you asked, like, what does quantization mean exactly? Okay, so quantization, the concept came from, say, uh, I'm talking about physics, it came from quantum mechanics. Okay, so where they said that the energy is always quantized in from one level of to another level. Okay, if you have learned the atomic model or something way back in, also in means your class 11, 12. In fact, a BSc, I think first year, BSc BTech first year, you also have some flavor of quantum mechanics. So it came from that. Okay, and also you, if you remember clearly, that energy is equal to what? H nu. Okay, so H is here what is a constant value. So if nu is 1 or 2, say for example 1 or 2 or any value in between that, so it can move in proportion of H only. If you find energy by frequency, you will have a constant, say k. So that is the kind of a least count you are getting, that okay, this step, this much amount of minimum step will be there. Okay, so that is the means concept of quantization here. Okay, so uh, so now uh, here in this there was a question like how this n cross e is equal to z h equation is valid, means coming. Okay, so what is z here? Z is impedance, which is defined as mu by epsilon naught, mu naught by epsilon naught, that is z naught. Okay, so if you see uh, electromagnetics from the perspective of physics, you have something called permittivity, permeability, and all those physical aspects or constants which explains you about a media. Okay, now if you see this, the explanation about the media, and try to take it from an engineering perspective. So you need to define certain quantities so that you can design something or go for something. So there are means multiple analysis done. Also, uh, if you might have heard about dimensional analysis in your high schools. So in dimensional analysis, some quantities comes means makes some unit. Okay, like mlt, these make some units. Okay, like ohms, ampere is also comprises of those things. Newton is comprises of those dimensional analysis. So those units comes. So based on that, what it is found that the mu naught by epsilon naught is coming in the units of ohms. Okay, and unit of ohms directly relates to the impedance or the uh, resistance of some from of some material. Okay, so and from that thing, the idea coined out to be like, okay, since we are talking about air or vacuum, that is also a media, right? So that will also have its own intrinsic resistivity or impedance, something like that, right? So from there, it this idea came out to be. This is the means kind of bit of history about these things. So 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 the if I talk in mathematic terms, so you know that h is related to b, means h is your magnetic field, which is related to magnetic flux by mu naught, means mu naught or mu b. Okay, then from that, what you can means if you see, you will get your z naught is equals to mu by epsilon naught. This is means like if you do by your hand, you will get it very easily. And why the here n cross is means, uh, if you remember correctly, what are the four Maxwell's equation relation? If you recall, the first one states Gauss's law, that is divergence of a electric field is equals to your uh, charge density, volume charge density or charge density by the epsilon naught, or the means permittivity of the media. Okay, so this is the Gauss's law. Second one is divergence of B is equals to zero, which says that monopole doesn't exist. Or divergence of B or H, whatever you say. Okay. Now the third one is del cross E is equals to minus dabba H by dabba T. Okay, that means if a field is circulating, the curl of H means like curl of E means what? There is a circulation happening. Okay, if E is circulating, that means it is generating a time varying magnetic field. Okay, so this is what it means. Okay, so here n is your normal vector, normal vectors. N represent here your normal vector which is normal to the plane. And if you cross that by E, that means E is circulating around that normal vector, or E is in a plane, means is on the plane which is perpendicular to the normal vector. Okay, so that means that will if you have a circulating electric field, there will be a magnetic field there, right? So since there is only means field on one plane, you will get saying that the field is circulating, means electric field is circulating, assuming that you will get a magnetic field there. Okay, so and the relation of that is related by Z. But you need to keep in mind that here it is assumed that the electric field is already circulating around it, so around a point. Okay, so that's why this relation is coming, and this is for plane wave in free space. And we know that in for plane wave to occur, you need time varying magnetic field, and which contributes to time varying electric field, which makes time varying electric field. Okay, so I hope this is more clear to you. And also I would like to means if you are more means towards derivation and all, and you want to see more derivations, okay, more derivation how they are done, then I will suggest one that uh, electromagnetic field theory by transmission and transmission lines by GS and Raju, that has means all the means step by step derivation in that, so you can refer to that. Sir, already.
Yeah, hi. So, how many people have joined?
So, yeah, 8.
Oh, just. So, anyone, can you hear us? All of us? All of you? Oh, you have to be unmuted. Okay. If you have any question, you can raise your hand. There is an option in the Zoom box. They can, yeah.
Hmm. They can,
You can raise their hands, right? I think
they
so.
can unmute also. See, this one is unmuted.
Oh, okay. Anyone asking any question? Okay, we can go by one. Dip, yeah. Hello. Diptangshu Banik.
Yes, sir.
Yeah. Do you have any questions for us?
Sir, I had one question, sir. I am a BTech student, sir.
Okay.
So far, it has been a bit difficult for me to follow the course because some of the concepts are a bit unknown to me, sir. So,
I
can
see.
you suggest some bridge material which I could follow to understand better, sir?
Which year you are in?
Sir, I'm just in the first year, sir. My semester exam started today, sir.
Oh, okay. Yeah, I think so. You should. You need to have and you have that first year physics course. Have you taken that?
Yeah, sir. First year physics course was there for everyone, sir.
Okay, that has been over in the first semester only, right?
Yes, sir. We studied applied physics in the first sem, sir.
Okay, and it has electromagnetics, the basic Maxwell's equation, etc. was there.
Sir, we had electrical circuits, but we didn't have Maxwell's equation, sir.
Okay. Fine. So which particular lecture you find it the most difficult? Can you tell us, point us?
Sir, I didn't have much issue in first week. It started from week 2 onwards, sir.
Week 2 was regarding the radiation fundamentals, right? Okay.
Yes, sir.
And week 3 was antenna. Week 4 was signals, receivers. Yeah. And week 5 is the single dish. Yeah. Okay. Okay. So week 2, week 3, week 4, all of them are problematic for you. I mean, when it comes to so we are using basically some application of the electromagnetics, which so okay. Have you done any course on electrostatics, magnetostatics, dynamics, etc.? Nothing.
No, sir, I haven't done anything yet, sir.
Okay, so I think my suggestion will be to have a book handy, like something like Griffiths or White. We will give you some references that might help to understand. But I think I agree that first year BTech may be a bit difficult, but we will see how to make it easy. Okay, for you. I think right now what comes to my mind is having an undergraduate textbook on electromagnetics will be the best thing. Which what is your major?
Sir, my major is electronics and communication engineering, sir.
Okay, so eventually it will be okay, but I think for the first year it may be a little bit yeah, a bit ambitious. I agree with that. So you can start with undergraduate textbook on electromagnetics, like or dynamics. I mean, Griffiths will be fine. Okay, which gives
Yes,
you
sir.
the basic relationship, how to calculate electric field, magnetic field, then basically what happens with the hydrodynamics part, Maxwell's equations, essential. So we have tried to cover a bit, but as you know, this is a prerequisite kind of like what you should expect. And we also told, I think, in the beginning of the course, or even in the flyer, that's the thing. But yeah, I think let's start with that, and we plan to hold one live session every week from now, so that yeah, so that we can have a discussion with you. We may not have anything to present because there were a couple of errors in the assignments also, typo, which we also found. So we thought that it's better to have an interaction so that you can come and talk to us. And if this is helpful, then we would like to continue once per week. We can have a time to discuss essential issues you're having. We are also doing it for the first time. It's the first time a radio astronomy course is there in NPTEL, which is good and timely, but that also has a lot of other responsibilities that we have to answer. A new course has its own issues and prospects. So we will be happy to join once a week if this goes well. Yeah. So Diptangshu, I think, why don't you start with that and post some more in the discussion forum? We will follow you. Okay. Any issues, just post in that, and we can. Even I am given my email ID also. So if you have any issues, you can post me directly as well, and I will try to answer. Okay.
Yes, sir. I'll get a UG book on electromagnetics and I'll follow the course accordingly, sir.
Correct. Yes. And then you can again revisit, and I can also, we can also post some more literature on the in-between contents also, and try to summarize once more for people who are a little bit lagging behind or are a bit junior than what we expected. We can dedicate a couple of lectures for them as well in the upcoming weeks. Yeah.
Yes,
I think
sir.
we are almost approaching the middle of the course, so it's good to stop for a few lectures and just go for a review. That will be good. Yeah. Okay. Thanks. We note it down. Next.
Thank you for the help, sir.
Thank you. Thank you very much. Yeah. Next on my list, in arbitrary way, I am seeing the name Tanveer Ahmad. Sorry if I'm mispronouncing your name.
Yes, sir. Yes, it's actually the
Hi.
Abhirup and you are correct, sir. So first of all, thank you for giving us the course that we mostly wanted to stay ready for years, sir. Introducing it for NPTEL, it's so much good to study, sir.
Thank you. Thank you very much. I hope we have some initial glitches, but I will promise that we will take care of all the issues, and if there are any any miss typos or anything, don't worry about the evaluation part. We have taken care of it already. If there is a typo and you have answered wrongly or rightly, that whole thing will be taken off, and we will have one more assignment in between, or we will get it accordingly. Don't worry about it. We are correcting as we are moving along. So anything we can, any questions you have, Tanveer, for us?
So the thing is, I'm currently pursuing mechanical engineering, sir, but I have this specific interest in astronomy, and I have attended some workshops in radio astronomy. When I go through this course, it's just a bit hard for me to grasp all the things, because I think I discussed with my friends in EC department. They said these all portions they studied in their second and first year. So for me, in other department other than ECE, so it's just get a bit hard for me to get through all these concepts at once in a while, because in each week I have to get all these courses. So it just gets a bit.
So which year you are in right now in ECE?
Sir, I'm mechanical department, third year, sir.
Oh, mechanical department, third year. Okay. Yeah.
Yes.
So I think so we actually wanted all of you to be exposed to this particular field. Okay. If you see the type of assignment we are giving, we are not expecting you to learn everything what we are sharing. It is more like for completeness, because if we miss something, they may be so for some others, I mean, because it is a broad spectrum course, right? It is available for juniors, seniors, as well as people who are actually trying to take it up as a course in a master's level or something. So that's why what we have teaching is that there is some minimum understanding you need to have, but the details is sometimes just there in our presentation for completeness. Okay. So that if you want to dig more, if you want to dive into it, you have the direction how to go in. Okay. the basic concepts we outlined, that you need to know at least how the antenna radiates. Okay, it's not required for you to know exactly which antenna radiates in which way. Like we showed, like last week only, we showed this the connection between, it's just coming to my mind right now, but there are more instances I can discuss more, is that we're discussing about this Fourier transform relationship between the aperture field distribution and the far field pattern. And there we used multiple aperture cases, but we told that is for basically for completeness. If you understand one, that gives you the concept clear, that is all we wanted to understand, that there is a relationship which is Fourier transform between the far field and the near field, and that's all. Okay. But yes, you have to understand Fourier transform. That is one other concept which is essential to understand what happens next. Okay, and the signal to noise, and etc. etc. So what I can do is, we can take one lecture in this coming, we can devote one lecture in summarizing what we have done so far and telling you exactly what we want you to at least retain the minimum from this particular course. The rest you can treat is as a way that if you can come back to it after some more reading, you may get some more hint that, okay, how to proceed in one direction. Supposedly somebody really want to study the radio antennas, okay, then there is something for them in the week number 3, which how to proceed on that direction, okay, in that manner. So yes, I mean, some parts. So which part particularly you are feeling very difficult to understand? We can note it down.
So when it comes to the starting sessions, I can understand the basics a bit. So when it comes to the core, like signaling and antennas, it's just a bit off my field because I'm in mechanical, and that's what not. But still I wanted to learn all these things, but it's just a bit of entirely different things.
If we suggest some more books or materials, will that help?
Yes, for sure. Like this, like that we can help.
So let's see. Let's try for one more week and then see if we have the next week's live session. I cannot promise now, but if we have it, if we have time for that, we will definitely like to have one more session next week, and then we can again revisit your case and see if that is helping. But we'll definitely come up with a summary lecture, at least one of them, in this week or early next week, to summarize what we have done so far. Okay, great.
Okay, sir.
Thanks. You can get in touch with us in the discussion forum, or you can directly email me. The email ID is there at the end of every slide, so that will be good. Okay.
Thank you.
Thanks, Tanveer. Next in my list, it keeps on updating, but it is coming up to be Ambarish Banerjee.
Yes, sir.
Hi. Do you have a question?
Yes, but I have wanted to watch on this course. I am a master's physics student. At now I have no question. Not question. I some late to join.
Okay. Fine. Thanks, Ambarish, for joining. Next, Arya Bhatta. Wow. Okay.
Hello, sir.
Hi. How are you?
Yeah, fine, sir. Sir, I do not have a question. Basically, I'm a first-year student, UG, and the course is I'm able to get some of it. I could say most of it because I have some prerequisites of what it needs to be learned. I'm able to get all those points, but while doing problems, it's like 50-50 in the assignment. I was able to score exactly 50-50. And just one suggestion I had, if we were...
Yeah, you are muted, Arya Bhatta.
Hello, I'm audible.
Yeah, now you're audible. Yeah.
Yeah, like if we were provided the solution of the assignment, then we will be able to see where we are going wrong in our particular pursuit. Because I have noted down every question and
Yeah,
noted
yeah,
down the
yeah.
method I have.
Actually, we will show in this slides also. We will share it with you also.
We actually have shared with the NPTEL, but I mean they might be releasing it soon. So we'll inquire about that the solutions. And basically we have discussed about the solutions also. So you can understand even the typos which we are talking, they're not actually typos, but it is basically something like some questions may have a different way to interpret. So we haven't given enough. It was not self-sufficiently made question, and apologies for that. So yeah, I mean we have no problem in making the solutions available to you. Yeah, no problem.
Yes, only that one suggestion from my side, and the course is actually really good. I have attended some workshops in Ayuka, and there I was like completely flabbergasted. But now I'm able to like get hang of what it's like to be in this stream.
Okay, great. Thanks a lot. Thanks a lot. Congratulate to all of you. India has landed finally on the moon just few tens of minutes back. And it's a really momentous occasion for all of us. I was just delayed because of that. And yeah, great news. So yeah, all astronomers all over, all where. Okay, yeah.
Sir, I have a queries. I have
Please.
one query. Yes, sir. Sir, in the lecture, we in the lecture slide, I have calculated accordingly as far as the lecture schedule from myself. But my question is that at the end of the each slide, particularly each week slide, there are some 4 books for radio astronomy and antenna theory. So I could not follow the 4 books simultaneously. So can you suggest some
I see.
one book?
Okay. No, I think, okay, fine. Our point in that particular slide is that
Yes, sir.
see, sometimes we are not creating content. Okay, we
Yes,
are
sir.
either borrowing content from books, materials, etc. Okay, even if we type it out, we are still typing out the equation which is belonging to some book. Okay, the way
Yes,
the
sir.
author have presented. Okay, I am not recreating those. We may be changing the way of presentation based on my interpretation of the thing and how I would like to present to you. However, material content may be borrowed exactly from some books, like particularly the figures, the
Yes, sir.
explanations. Okay, so it is very much due upon us to acknowledge those references
Yes.
from which we are taking the material, and that's basically for that. If you want to look into 1 or 2 books like that, we
Sir,
can
yes.
refer, okay, for
Yes, sir.
each weeks, which particular book you can refer and which particular chapter you can refer in that book,
Yes, sir.
we can
Yes, sir.
suggest. Okay.
Yes, sir. That
we
is
can do.
very important for me, because I am calculated the actually if I say one example, the large dipole antenna. For that I have mathematically calculated all things by my own. But when I look at the end of the slide, then the 4 books I could not follow simultaneously. So
No,
that
sure.
also my
I got your point. Thanks.
yes, sir. Yes,
Thanks
sir.
for pointing it out. We will definitely share that as a
Yes,
part
sir.
of one of the next slides. Yeah, no
And
problem.
very good, very good. I am continuously following this course.
Thanks a lot, Ambarish. Thank you.
Yes, sir. Yes, sir.
The next in my list is GB Raghav Krishna. Yeah. Hi. Can you speak up a little bit, because we're unable to hear you?
Hello, am I audible?
Yes, perfectly. Thank you.
Yeah, good evening, sir. Thanks for this wonderful course and for providing us with these beautiful lectures. I have completed my BSc in physics and currently I'm preparing for entrance exams. And I have to mention one more thing. I'm a member of Brad at Home India Collaboratory. Have you heard about it?
Yeah, yes. I know Anand also very well. Yes.
Yeah, I'm an astronomer in that collaboratory. So I believe this course will be very useful for me. And I have a few questions. First is, can you provide me one single book which covers antenna theory, signal processing, as well as data processing? Because it is difficult to follow multiple books while preparing for entrance exams at the same time.
No, I understand. The stuff is that Raghav. Can I call you by Raghav?
Yeah. Yes, sir.
Okay. I think what I particularly find is that several things are not as elaborately done in each of the books. Okay, like there is essential radio astronomy, which is more oriented to go to the science as quickly as possible and do the essential bits and pieces, but it assumes that we know a lot of other background information from before. Okay, there is something another called tools of radio astronomy, which actually is very well placed, but again it some of the derivations or treatment I like it better in others. Okay. Similarly, there are antenna books which talks about a lot behind antenna derivations, etc. So what if okay, I can give you one book which is which can cover the overall thing. I think tools of radio astronomy comes very close to that. It's a neutral. I would say I'm neutral with that because it does equal emphasis on all the chapters as we are going. If you are a little bit new to the entire thing, you may try with that CRC Press's book, The Fundamentals of Radio Astronomy or Astrophysics. I forgot the exact name, but it has I think there's somebody called Snail, Mar. They're the two authors among the author list. There is one by CRC Press that is a good book, and these tools of radio astronomy, which is Wilson and Rolf, and one more author is there, which is from Springer. These two are good books to have, depending on whether you are starting or whether you're a little bit habituated. You can start with CRC Press one and go to that. But I can provide one book for each week because that is more easier.
Yeah, I get it.
But it is yeah. So I think if you take with one, like for when we come to interferometry, then there's another book which is more interesting and important. And when you come to the science part of it at the end, there are other books which are dealing with these things better. Okay, so you understand that. But yes, if you are limited to one book, I would say these two you can take a look.
Okay, and the next question is, sometimes the questions in the assignments have typos and the answers are not matching. For that, I've used ChatGPT, but Mr. Harsha said that it's not correctly used, but I got the same answers that provided by ChatGPT. So
for this, I will say see your question number 14 or 13, where you have to calculate the ERP, right? So if you see the numerical, you will see that 10 to the power 1.1 ChatGPT is saying is coming out to be 35, but 10 to the power 1.1 is around 12.
Yeah.
Okay.
Okay.
So actually, I have also played with ChatGPT and saw it does lots of silly mistakes, which leads to some silly mistakes in final answers. Okay. So even if you are using ChatGPT, just go through the formulas and numericals by yourself also.
See the purpose. Okay, I will not comment on ChatGPT.
No, why? The reason why I use ChatGPT was because last week I started the assignment at 11:30 p.m. That's why. That's a thing.
Okay, so I think you can experiment with that. But I think, see, the purpose of the assignment is that are you in touch with this week's lectures? Okay.
Yeah.
Mostly, I am. Because see, from our side also, this is a new course. We know we are mostly inviting people to come and learn radio astronomy than to penalize you for not learning. Okay, so mostly to encourage. Okay, so please take it like that. And assignments are essentially to again and trying to make you touch base with the basic concepts which we would like you to retain at the end of this week. Okay, that's a try. I hope we have been successful a little bit towards that. And
Yeah,
whether you
your
use
lectures are very
ChatGPT or
good.
not, I will not be able to comment on ChatGPT part. I have not used it so far, so I don't know. Harsha says
Okay.
he does.
Yeah, but
So
your lectures and you making us understand the concepts is very good. I have to
Thanks a lot.
thank you.
Thanks a lot. We will try our best. I think sometimes it's late at night for us also to record them. So yeah, I think it's great. So let's carry on.
And my final question is that
Oh yeah. Okay.
how would the final exam will be conducted?
It will be numerical types as well as MCQ based. Okay.
So like same questions, same type of questions that we get in the assignments. Is it like that?
More or less, we are also trying to look into that because as we progress, there can be a little bit more things come in. We may have to change a pattern a little bit, but not too much. Like no subjective questions, etc. Nothing.
Okay, can you provide us with the sample question papers before the commencement of the final exams, like in October?
We will see the opportunities given to by NPTEL to us, how this can be shared. We will frame it and send it.
Okay, thank you, sir. Thanks for providing me with this wonderful opportunity.
Thank you. Ketan Hari Krishna.
Hello, sir. Is it audible?
Hi.
Sir, how is radio astronomy helpful in cosmology to understand cosmology?
It's a great question. But I am a cosmologist and I am radio astronomer too. So yeah, I think radio. So as we discussed in the first slide only, that signals from the universe comes at all wavelengths possible, at entire electromagnetic spectrum. So there are certain signals which comes in radio bands, which comes from very far away. That the cosmic microwave background actually also was in the microwave regime, kind of part of high frequency radio astronomy, you can say. So if you want to do cosmology, radio is a very potential area to do that, because we study, like myself study this hydrogen line from very early stages of the universe, and through studying those lines from that early stages of the universe, we probe the nature of the sources, how the universe evolved in that early stage, etc. People who studies cosmic microwave background, they study extremely early universe, which can be seen by us. The signals before that do not reach us. Okay. So yeah, radio astronomy is very much synonymous with the cosmology in that sense. Of course, there are other probes of cosmology in other wavelengths also, and they are equally important, if not more. But we do contribute from radio astronomy side a lot to understand, increase understanding in cosmology.
So how to proceed to study the radio astronomy? Because I'm currently EC. So
you are in which year?
4th year, sir.
EC.
Yes, sir.
Yeah, I mean, if you want to do higher studies in astronomy or cosmology, there are several master's programs in astronomy in India also, like IIT Indore offers one. There are other programs outside India also. MS programs in astronomy, astrophysics. If you want to do a PhD after that, you can also do that. So the possibilities are there. So yeah, option is, I mean, you can visit our web pages for MSc Astronomy. You can see there is a lot of details we have given. If you want further information, you can also write to me. I can share with you.
So one last question. Can you exactly differentiate between specific intensity, total brightness, flux density, and luminosity? Because they're all are nearly close to each other. So terms.
Yeah, we had a discussion, very candid discussion in that particular lecture also. It's very confusing, and you will be surprised to many even seasoned PhD students also, that which varies with distance and which doesn't vary with distance. So we had the discussion there, and we can suggest you more books to go and read. I think that was quite explanatory, I think, by itself. If you need more explanatory examples, we can give you so that you can understand it better. Is that what you want? I thought
Yes,
the
sir.
lecture was good. Yeah. Okay. We can add more more in when we do the review. Lecture, as a part of that, we can give you some review examples from the previous lectures, previous weeks. That can give you a good handle of. Somebody was asking for sample questions, so that can be part of that stack as well, so that it can help you understand. Okay.
Thank you, sir.
Okay. Shriya.
Hello, sir. Good evening.
Good evening.
Sir, actually, I was solving the assignments. So I am like a bit confused in some questions, and then I don't know how to proceed like for that questions, because there are not much references related to the subject available everywhere. So can we have some like some tutorial or something more, so we can like go on the practical application parts, like solving questions, like apart from this theory lectures, like once a week?
Yeah, we tried in the first week or second week also.
Yes.
That have a tutorial session separate, and from second week onwards, I think we had merged them together. Of course, in the last week we had a little bit less number of solved problems. I agree with that. We noted it down, but sometimes there are no solved problems, and it is more for completeness. But we will try to keep a good balance. And I think what we discussed was that instead of having a one session for just problem solving, we were taking up individual problems in the at that particular moment when we are discussing that concept. After that, right after that, we were discussing the problems which may arise from that.
Yes, sir. Yes, sir. That was also helpful, sir. If we can do more of them, it would be very helpful, because
Fine. We will have.
Yes, sir.
Because as we said, we were coming to the middle of the course almost. So we will spend a couple of lectures to review the entire material we have done, and some more problems for that reason. Okay, no problem. We will do that.
Sir, also can we have the solution PDFs or something for the previous assignments we have done? Sir, actually, it is very difficult to proceed further week before completing.
Okay, let me tell you a practical problem is that we have provided. Now we will find out from NPTEL how to communicate that. Okay, we will do that. If that is available, we will definitely do it immediately. Okay.
Okay, sir.
Sure. We'll take it. Sure.
Thank you,
So
sir.
I think we can have a weekly or a bi-weekly review, kind of, so people can join, because I see that less people have joined today. But anyway, okay.
Yes, sir. Thank you.
Thank you. Sangeeta.
Good evening, sir. Sir, actually, I have completed my BSc. I wanted to MSc in astronomy, sir. So how should I approach this course, sir?
Okay, BSc in physics.
Yes, sir.
Yeah, so I think if you have done BSc in physics, the basic electrodynamics from the Griffiths part is already should have been covered, correct?
Yes, sir.
Yeah. So I think then it may appear as a little bit steep, little less steep learning curve than the others who are like a first year BTech. So I would suggest that have you are you in trouble in understanding some of these electromagnetic concepts, and are you having issues for that or no?
No, sir. I'm actually fine with that. First
Okay.
week, I find it like new and difficult, but I have already studied electromagnetic theory, so it's fine for me, sir.
Okay. So are you facing any trouble in the later weeks or?
Sir, actually, I find it a little difficult to understand this antenna theory. I feel like there are much topics covered in that week, so I'm not able to finish all the topics. So,
Okay, I agree. I also agree with you. Okay, what we can again, as we are saying, that we will devote couple of lectures to review the material which was covered up till now, and actually give you a little bit more number of review lectures. So and also it is okay. So sometimes it is told for completeness, in a sense that if somebody really likes that portion, okay, and really want to go into deeper, they would probably may enjoy those portions, okay. For some, for the others, we would like them to only retain few of those and not the entire part. Um, but having said so, it will be a little bit confusing that we may not have always demarcated that up to which it is you should know, and from here you may skip as details, okay. In last week, like for example, there was a lot of details of the single dish observation. I just simply said that these are extreme details. If you remember this much, that is sufficient. But supposedly somebody really want to take it up and understand from this material itself, the material is there for completeness purpose, okay. So one thing we can do, we can visit those first few weeks and explain the basic things which you should take away from this particular course. And if you do not retain the rest, it's okay. It's just details and more for few people which who like to spend more time into antennas. Okay.
sure, sir. A review session will surely helpful, sir.
A review session will be helpful. Review, and we will follow that up with a live so that we can also get a feedback from you. Because it's also to just for your own benefit, and we are organizing this live sessions also to get your feedback from you directly. Okay, and if you have any suggestions or any other feedback, please write to me also. Okay.
Yes, sir. Thank you, sir.
Great. Amit Kumar. Huh? Okay. Okay. See, if there is no other question, yeah.
Sorry to interrupting, but this is a little out of the course related to course. But in my college, we're trying to build a radio telescope, and we have actually been able to detect the 21 centimeter line, and that was possible using some basic stuff only. We had a SNA, like noise amplifier, then we connected that to a band pass filter, and using the SPI software, we were able to detect the H1, like the 21 centimeter line. But now we don't know how to move ahead from that, because there is very limited content on how to actually uh, compile the data, or to get the data and store it and use it in a meaningful way to do get something out of that data. So is there any good meaningful course where we could also learn like how to build this stuff? Because I found that there wasn't any material or source that I could reliably go and get the information from.
You are right. Yeah, perhaps it is to take it up on offline. You can email me. We can discuss it further. But I congratulate you that it has been a really good sign that you have developed your own telescope, and it is the line itself. We have one in our IIT also, and there are ways to use it. I mean, like galactic rotation curve, particularly. Lots of usage are there. However, it is probably the materials put out there is not sufficient to understand and do it by yourself. We can, if you please write to me, we can point you to some others if that helps, or have a separate session to chat with you one-on-one to help you set up something.
Sure, sir. I wasn't able to find your email. Sorry for that, sir.
The last page of the 8th slide. Maybe it just chops off very quickly.
Yeah.
It's my name, Abhirup, ABHIRUP.DATTA at IITI. I can write it in the chat. 1 second. Oh, there are a lot of questions.
Same. Whatever you're asking. Live.
Okay. I'm just typing it in the. Please use the prefix as of your subject as NPTEL, so that we understand from where it is coming. Okay. Hello.
Okay, so thank you very much.
Great. So if are there any other questions? I don't see any. So maybe we can record this one and share it with with them also, this discussion.
It's not recording.
No. Maybe with you may have a few things left to discuss, right?
Yeah.
It's already 7, so maybe we can record this discussion itself in a recording and post it as a clarification.
Yeah, that can be done as a 2 minutes.
So whatever we wanted to also discuss with you about the previous questions we got, what we can do, we can simply record it in a video as an explanation or something, and post it also as a part of next week's content, so that you can at least go and look at it and understand more. Okay, that we can do. So what we will do is we will spend at least half an hour or at least one lecture or 1.5 lecture from now onwards to revisit previous week's contents. Okay, so that we can catch up. We can allow you to catch up with what is going on. Okay, we'll design something. This is what we are thinking out loud. So we'll address this thing by doing it more carefully and coming back to you. Okay. Since I don't see any other question, thanks a lot for joining this one. We will try to have more such, maybe one in next week also. Let us stay in touch. Thanks for joining us. Thanks for subscribing to this particular course. Hope it excites more students to join radio astronomy, take it up as one of the career or even just for fun. That's okay. Great. Thanks a lot. Good night. See you in the lecture next day. Bye-bye. Simply leave the